Welcome back for the fourth video in this series. In this video, what we will do is we will learn how we can replicate the results that we got earlier on the previous three videos using Excel with Stata. There will be a few more videos, one on SAS, one on Eviews, and one on SPSS, which are other econometric software that you might encounter in the future. However, in this case, we want to learn how to get started with Stata. As you can see over here, with Stata, I have two windows open at this point. The first window is the main window for Stata. This is a do file, which I will get to in a little bit. Stata gives you the opportunity, Stata allows you to open the data editor, which we can see up here, where we can see the data that we have already downloaded. Now I will clear this in a few minutes so that we can download them together again. However, I can also click on this little button up here that says New Do File Editor, which will open another do file where I can write my program in. Now, the do file allows you to save commands. You can add your commands either in here in the do file and save them for future use, or you can add them one at a time down where it says command. So for example, if I want to clear this data, I can simply write clear and press enter, and then all of the data is gone. And over here it gives me a history of all the commands that I have used. Now, if I go to the data editor, I will find that there are no data currently available in Stata. So what I have to do is I have to import the data, and for that I have created a new do file in the do file editor. Now there are many ways with which you can import data in Stata. My favorite way is to use the import Excel function. I have noted up here for the example one that when you write the command for import Excel, the path is not case sensitive, neither is the name of the file. However, the sheet name, so for example, I'm saying import an Excel file, I'm giving it the path where I have saved my file, which is called regression yt.xlsx. You will add your own path over here in your own name file. And then I'm saying that I want you to go into the file and look for the sheet that's called for reg. And that's because I have multiple sheets. If I do not have multiple sheets, then Stata will go ahead and find sheet 1 and import that for you, or whatever sheet is available. So here is for reg, where as we can see, we have the data that we used in the previous analysis. I'm also giving it the command that in the first row I have the names, and in the end I'm saying clear. So once I highlight this portion of the program and I press the execute button, as you can see, immediately on the right hand side I can see now that my data has been imported in Stata. I can see the data by looking at the data editor, so I'm going to click on the data editor, and I can see that I have my y variable, my x1, my x2, and my x3 variable. In order to run the regression, I'm simply going to highlight regress and press execute. Or if I want to run the whole program, I can just simply press execute as it is, and it will re-import everything. So here are my regression results, which are exactly the same as the ones that we had earlier in Excel. So let's go to the solve part. There we can see in this part of Excel, we can see that the constant was 5.28. There it is, 5.28. The coefficient for x1 0.74, 1.1, and minus 1.34. The coefficients, the t-statistics, and the p-values, they're all going to be 100% the same with the results that you got earlier in Excel when you used matrix algebra to produce them. So as we can see over here, the constant x1 suggests that when x1 increases by 1 unit, y increases by 0.74 units. When x2 increases by 1 unit, y increases by 1.1 units. When x3 increases by 1 unit, y decreases by 1.34 units. None of these variables are statistically significant, which I can see in either of three ways. I can either check t, the t estimated value, and compare it to a critical value that I can find from a table, or I can look at the p-value, which we can see that it is not less than 0.05. If any of those values were less than 0.05, then that variable would be statistically significant. However, in all three cases, x1, x2, and x3, these values are statistically insignificant. The p-value is more than 0.05. I can also see it from the 95% confidence interval. Since the 95% confidence interval contains the value 0, as you can see, it ranges from minus 0.12 to 1.61. Since it contains the value 0, that means that it is not statistically significant. Moreover, we see that the adjusted R-square is 0.28. We're explaining 28% of the variability of the dependent variable. And the F statistic, which we had estimated earlier as well, is 2.17. Also here, the p-value is more than 0.05. The model is not statistically significant. I cannot reject the joint hypothesis that beta 1 is equal to beta 2 is equal to beta 3, and altogether they are equal to 0. So in the next video, we're going to work with SPSS, SAS, and Eviews.